guys, this is Professor Janacek. I want to go over the intermediate value theorem. To start off with, let's let f be a function that is continuous on an interval a, b, and we'll let L be a number between f of a and f of b. According to the intermediate value theorem, there exists a value, we'll call it c, that's between a and b, such that f of c is equal to L. Let's go over an example to illustrate what's going on here. So in this example, I want to show that 3 times x to the fifth minus 4x squared equals to 3 actually has a solution on the interval 0 to 2. So to start with, we'll let f of x equal the 3x to the fifth minus 4x squared. We'll also let L be that function value 3. So notice that the L value is a function value. C, what we're looking for, is an x value. All right, to begin with, I need to take a look at this interval. Now again, our interval here, those are x values. So let's take a look. What is f of 0, the first endpoint? Well, that would be, looks like we end up with just 0, which is less than L, which is less than 3. And now let's take a look at the other endpoint, 2. Oh, this is going to be a bit bigger. Let's see, that's I think you end up with 80 there, which is quite obviously bigger than 3. So what this tells us is that our L value is between f of 0 and f of 2. So just to see where you are, to start with, I had that, we started off with our function. And by the way, I note that this function is continuous on that interval. And then I have my value L, and I just verified that it's between f of a and f of b. So that's all I've done so far. All right, so we have those two first lines. Then, by the intermediate value theorem, there exists some c. Now this c has to be between a and b. So there's a c between a and b where f of c is equal to 3. Actually, let me do it this way. Now I've gone ahead and graphed this so you can kind of see it visually what's going on. So we started off with our function. Of course, here's our interval from 0 to 2. And then we also selected this L value. There's our 3. That's L. And now notice we also, the next thing we did was calculate f of 0. So f of 0, that was 0. And we calculated f of 2, which was way up here, it's 80. And since L falls between f of 0 and f of 2, that tells me there must be some This is the big bit. There must be some value between 0 and 2 we'll call it C, that corresponds to 3. In other words, there's got to be this value C. I don't know what it is, but I do know that it's got to exist such that f of C is equal to L, or f of C is equal to 3 in this case. Maybe I can add that here. So that means there must be some value. I must have this C value that gives me a function value of 3. So there's got to be a solution, and that's the idea. It's pretty straightforward once you look at it, but it also can be very, very powerful. Enjoy!